Hi students, in this video I am going to teach about one of the method and the numerical methods. So numerical method it is a branch of mathematics. As we have already discussed about some method of numerical methods. So here the additional one more method which I am going to teach today, it is nothing but Newton-Raphson method. So Newton-Raphson method, as we have told, it is another method of which is one of the method under the numerical. So it is a special method which you can able to find the real root by using this method of a non-linear equations. So when you want to get a numerical result for the non-linear equations, you can use the Newton-Raphson method. So first we will see the Newton-Raphson method formula. So Newton-Raphson method formula, it is nothing but xn plus 1 is equal to xn minus f of xn by f dash of xn. So it is an iteration method. By keep on replacing your n value, we can able to get the iterations. It is nothing but n is equal to 0 in this equation. I can able to get x1 equal to x0 minus f of x0 by f dash of x0. Suppose you want to find out a second iteration, you can able to replace n is equal to 2, I can get my second iteration and so on. Based on your decimal requirement on your question, you can extend your iterations. So first we need to fix your initial value of x0. So how we can able to fix your x0 and how we can able to solve to get your real root by using this method, I can explain from one example. So we can go for the example. So the example is use the Newton-Raphson method. Find the cubed root of 37 with 3 decimal places. So you can read one more time the question. The question is a direct one. What has asked it? You have to use a Newton's method and to find, which you have to find is it's a cubed root of 37 and the condition also is mentioned. You have to do till you will get a 3 decimal accurate answer. So now you can start with a solution. As we have already seen the formula, we need to fix it first initial value to go for a iteration. So for that, first I can do that. First consider what is x, because I need a non-linear equation. So you can fix it. X is equal to cubed root of 37, which we are considering. Now take a cube. You can able to get x cube is equal to 37. Then take the 37 to the left side. It will become x cube minus 37 equal to 0. Now you can fix it your f of x, because in general nonlinear equations under the numerical methods, it is f of x is equal to 0. So whatever is there in the nonlinear equation, I can consider in f of x. Now you can go with your f dash, because it's a needed for the formula. So what is your f dash? So x cube, you can apply x power n formula. It will become 3x square. And 37 will go for the 0 since because of constant. So what we did, first we have considered x and we made it f of x. Then we have done your f dash. So now you can go to the next step. We need to fix your initial one by using your f of x equation. For that, what we are going to see that by keep on replacing your x value where I am able to get my cycle, that means the negative positive or positive negative immediate changes where it is happening, you can check. Since because the roots lies between the value which you can easily calculate by using a numerical, but what we needed, which roots lies between, that means which number between we need to find out. For that reason, we can replace x is equal to 0, 1, 2, 3 to get your cycles where you are getting a positive to negative, because at sudden the point which you are finding the root of the function, you can replace, it should give equal to 0. So that is the root of that equation. So using that, keeping in that mind, I can find it from 0, 1, 2, 3. So you can see in this slide, x is equal to 0 I'll get f of 0 is minus 37. X is equal to 1. I'm getting f of 1 is equal to minus 36. Similar, you can replace 2. I'll get minus 29. X is equal to 3. I'm getting minus 10. Yeah, you can see here what is that? X is equal to 4. I'm getting a f of 4 value is 27. So you can see 3 and 4 we are having a negative to positive changes. That means you are getting a opposite sign. So your answer must be in between of this 3 and 4. So now I can fix it my x naught. So see to that which value will be near to your 0, that value you are supposed to fix it. That means which x value to replace, f of x value is giving it's near to 0 will give your best approximations. So what is that? The roots lies between 3 and 4 as we have seen in positive to negative cycle. Now I'm considering x naught is equal to 3 because f of 3 is minus 10 which is near to 0. So I can find it immediately. Your f dash of x is what is that? It is nothing but 3x square. Na? So replace x is equal to 3 in your f dash. It will be 3 cube will give 27. Now your x naught is ready. F of x naught is ready. And f dash of x naught also is ready. Now I can start my iteration. What is that? We know already the formula for Newton-Raphson. It is xn plus 1 is equal to xn minus f of xn by f dash of xn. So now I can replace n is equal to 0 to get my first iteration. x1 is equal to x naught minus f of x naught by f dash of x naught, which is equal to x naught as we fixed it. What is that? 3, right? Minus of minus 10 by 27. So I can get my x1 value by using the calculator. We can easily calculate. So your x1 value is 3.3703. It's clear na? So just you can substitute your x naught, f of x naught and f dash of x naught in the formula. And just you do the simplification by using your calculator. You can fix your x1. Now I can go my f of x1. Because I need to compare the exact minimum 3 decimal places. So you can go for a second iteration. For that I need f of x1 and f dash of x1. So replace this current x1 value in f of x function. So you will get f of x1 is nothing but f of 3.3703 will give 1.282. Then f dash of x1 is nothing but 3.3703 whole cube. It will give, what is it? 3 into 3.3703 the whole square. It will give 34.076. So once you have found your f of x1 and f dash, I can move to the iteration number 2. What is that? Substitute n is equal to 1 in a formula and you will get your x2. What is that? Xn plus 1 now. So it will become x2 equal to, there I have a xn. It is nothing but x1 minus f of x1 by f dash of x1. So which will give 3.3703 minus 1.282 by 34.076. So now you can use this calculator and you can simplify. I can get my x2. So x2 is nothing but 3.3313. So now you can see the iteration number 1 and 2, only the 2 decimal will get match. I guess only 1 decimal because it is 3.3 only it's getting matched. So obviously I should move on to next iteration. So n is equal to 2, you can replace in the formula. You will get your x3 which is x2 minus f of x2 by f dash of x2. So now 3.3313 minus that f of x2 value and f dash of x2 value. You can substitute and by using the calculator as usual you can simplify. I can get my x3 is, what is that? 3.3314. Now you can compare your second and third iteration. Exactly 3 decimal it's getting matched. It is nothing but 3.331. So you have exact 3 decimal match. So you can conclude the result of the given question. It is exact 3 decimal places that is x is equal to 3.331. So that's all your solutions for the Newton-Raphson method. So I can give one more example which is used by Newton-Raphson. So the next question. Using Newton-Raphson method, find the real root and correct to 3 decimal places cos x minus x into e power x minus e power x is equal to 0, which lies near x is equal to 0.5 and x is in radians. So in this question you have to remember always, whenever the trigonometry function has been appeared, the equation is there, you need to calculate in the numerical. You're supposed to change in your calculator in the mode radian. So you can use the mode button to change your degree to radian. In the calculator, right side corner, it will display as an R. So it will be converted in radian mode. So yeah, now we can go for the solution of this question. So what is that? I have a function f of x equal to 0. What is your f of x? It is cos x minus x into e power x. And additional what has been given already, which is lies near x is equal to 0.5. What is it meaning? Your x naught is already has been given, it is 0.5. So no need to verify where it is will be lying it in between the values. So what you have to do, directly I can go my f of x is cos x minus e power x. Now find your f dash. What is your f dash? Cos x differentiation is minus sin x and x e power x. What you have to do? I have to apply my product rule. So x into e power x plus x differentiation will give 1 and e power x. So minus is there. So both will have in the minus sign. So this is all your f dash. Now I can fix it my f of x naught and f dash, since we have already have given in x naught. So use in your calculator. Don't forget it's supposed to be in radian mode. So what is that? F of x naught is nothing but cos of 0.5 minus 0.5 into e to the power of 0.5 should give 0.053. Similar, you can replace in your f dash, it will give minus 2.95. So we have found already f of x naught, f dash of x naught. Now we can move into the iteration number 1. What is your iteration? X1, yeah, in the formula I can replace. What is that? N is equal to 1, isn't it? No, n is equal to 0, I can replace. I can get my x1 iteration. What is that? X naught minus f of x naught by f dash of x naught. So you can replace, and 0.5 and your f of x naught value, f dash of x naught value, you can reach your x1. It is 0.518. So here also it is a correct to 3 decimal. So obviously we need to go for your next iteration. What is that? F of x1 I have f of 0.518, you can calculate. I can get 0.105, and similar your f dash of x1 will give minus 2.86. Replace your f of x function and f dash of x function for your xn value you can get. Now you can go for your second iteration by using your x1 value. So substitute here in the formula of x2 equal to x1 minus f of x1 by f dash of x1. I can get my x2. So let me see what is your value of x2. Yeah, x2 is 0.5185. So you can compare the x1 and x2. So you are getting exactly 3 decimal match, right? 0.518 and the x1 also 0.518. So the exact 3 decimal is x is equal to 0.518. So you can able to do any kind of problems by using a Newton-Raphson method. Easily you can get your numerical result. That's all. Thank you.